Okay, so today we're going to talk about rhombi, and squares. So the plural of a rhombi, or the singular, is a rhombus. So rhombus and a square. And so as we speak through these items, we're going to be talking about the different shapes we've already discussed as well. So the first thing is we've talked about on this sheet right here. Let me see if I can get this going here. On this sheet over here, scooch this over. There we go. Okay. A quadrilateral, okay, is a four-sided figure. Okay, so this is a family tree. So a four-sided figure is a quadrilateral. Also, if you have a four-sided figure that's called a quadrilateral, that's a definition. So, you can kind of even highlight that to be like, okay, if you have a quadrilateral, the definition it has four sides. And then also the interior angles, I should use a pen, interior, of a four-sided figure is 360 degrees. So four sides, and the interior of a quadrilateral adds up to be 360 degrees. A parallelogram, okay, we can talk about that. A parallelogram, by definition, okay, is going to be opposite sides parallel. Okay, so you can signify this by putting little arrows on the opposite sides and say, hey, guess what? These guys are parallel. Okay, opposite sides are parallel. And then the next thing would be opposite sides are congruent. Okay, so if you look at a parallelogram, you'll notice that the opposite sides are congruent to each other, as well as these guys are congruent to each other. So opposite sides are parallel, and that's by definition of what a parallelogram is, hence the word parallelogram, opposite sides are parallel. And then opposite angles are going to be congruent. Okay, and so if you want to kind of show this on your picture, be like, oh, look at this angle here matches this angle down here. Those will be congruent. You can, draw like, a single little hatch. Be like, oh, look at those are congruent. And then these opposite angles here. So this angle here is congruent to the one down here. And these are getting a little sloppy, but you can kind of see this angle matches this measure right here. So opposite angles are congruent. And then adjacent angles are going to be supplementary. So adjacent are supplementary. So if you add up consecutive angles, they make 180 degrees. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, adjacent angles are supplementary, and the last one would be that the diagonals bisect each other. So diagonals bisect each other. Okay, and so if you look at a parallelogram, you will notice that if you draw a diagonal and you draw another diagonal, these guys match each other in length, and then these guys match each other in length. So the diagonals chop each other in half. So if you have a quadrilateral and then it's also a parallelogram, it shares the features of quadrilaterals as well as the features of a parallelogram. Another thing we can talk about would be rectangles, and we learned those yesterday. So rectangles are parallelograms who are quadrilaterals who also have two additional features. Okay, kind of like the new upgrade for your phone. Okay, so a rectangle has 4 right angles. That's kind of the easiest way to talk about what's a rectangle. It has 4 right angles. And so you can draw 4 right angles there. And then it's a rectangle is a parallelogram with 2 more features. So one feature is that it has 4 right angles. The other feature, it has diagonals are congruent. Okay, and so if you drew a rectangle and you drew the diagonals, you'd notice, hey, those diagonals are congruent to each other. And then also, they bisect each other because it's also parallelograms. So each of these little pieces here on each diagonal will match each other. So all 4 of those little segments are going to be congruent to each other. So if you have a rectangle, it's part of that family of quadrilaterals it's quadrilaterals who are parallelograms who are also rectangles. And so rectangles have all the features of a rectangle as well as parallelograms because rectangles happen to follow those. And so the 2 shapes we're going to learn today will be a rhombus, okay, so, and we'll talk about these right in a second. If you've got a parallelogram who is also a rhombus, the additional features they have would be threefold, okay? They have all the sides are congruent. Okay, so all four sides of a rhombus are congruent, so you can mark that on your cute little shape. Okay, all four sides are congruent. And then also the diagonals meet at a right angle. Okay, that's diagonals are going to be perpendicular. Okay, diagonals. And then the last one would be that we've got four congruent sides. We've got perpendicular, and then also that the diagonal bisects, okay, the opposite angle. So diagonals bisect the opposite angles. And we'll talk about what that means. And so if you've got a parallelogram who is also a rhombus, you'll notice that all the sides are congruent. The diagonals, if you drew them, are perpendicular to each other, and then the diagonals bisect the opposite angles. If you happen to have a rhombus that is also a rectangle, okay, and the main features of a rhombus and a rectangle would be all sides are congruent, coupled with four right angles. Think about that. If you had a rhombus that had all sides the same, okay, but then wait a minute, all of them are right angles, then you would have a square. And so that's going to be the last thing. So if you have a parallelogram that obeys both the rhombus rule as well as the rectangle rule of all sides congruent as well as all right angles, you will have a square. And so this is the only regular quadrilateral. Okay, and so it shares all the features of parallelograms. It also shares all the features of rhombuses, all the features of rectangles. A square has every single one of those properties there, and it's going to be regular, which means it's going to be quadrilateral, or it's going to be equilateral as well as equal angular. So we can use this chart in a minute to be like, okay, let's go through these notes about rhombi and squares and be like, okay, can we refer to this to help us organize our thinking? So a parallelogram has opposite sides parallel. And you can talk about the features of a parallelogram, and those are the ones below. You could also say, oh, I encountered a shape that has, any of these features, and you're going to have a parallelogram. But the most common way that you've got a parallelogram would be, the opposite sides are parallel. And now, of course, in every parallelogram, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, the diagonals bisect each other. Like remember if you draw this, these guys bisect each other, and so you've got this equaling this, and this guy equaling this one right here, and then also each diagonal forms two congruent triangles. You can go back to your notes for parallelograms, but those are principles that apply to all parallelograms. Well, some parallelograms actually they can become a rectangle. They are a rectangle. And so what do you mean? Well, what's the definition of a rectangle? That it has four right angles. So if your parallelogram has four right angles, you will have a rectangle. Okay. And if you have a rectangle, it has all the features of a parallelogram, but also two additional ones. That each angle is right, okay? Every angle is right. And then also your diagonals are congruent to each other. So this diagonal is equal in length to that diagonal there. And so that means that each of these little pieces are going to be congruent, which is pretty cute. And then here's something we'll learn today. And what we're learning today is that if you've got a parallelogram and you say, okay, well, I've got all four sides congruent, okay, you're going to have a rhombus. So what's the definition of a rhombus? A parallelogram who has four congruent sides. And most rhombi look like this, with all four sides congruent, and the special features of a rhombus would be as shown. The diagonals are perpendicular to each other. So here's another example of one. They meet at a right angle. So that's a right angle. When you look at the diagonals, they meet at a right angle. Also, you'll notice that each diagonal bisects the opposite angle. So if you draw this diagonal right here, it chops in half this angle on the right, it chops in half this angle on the left. So it forms two congruent angles on the left and right. And then the other diagonal, okay, the other diagonal bisects this angle here. So this angle matches this angle over here. So this one matches this one over here. So each diagonal bisects the angle, the opposite angles. And this last one we don't deal with very much. So the main features would be if you have a rhombus, which is a parallelogram with four congruent sides, well, then the diagonals will be perpendicular. They meet at a right angle, and that it bisects the opposite angles. So what are the character qualities of a rhombus? Okay, let's check these out. Well, because it's a parallelogram, it has all those parallelogram properties, which would be opposite sides are congruent and parallel. Because it's also a parallelogram, both pairs of opposite angles are congruent, and adjacent consecutive angles are going to be supplementary. And then also diagonals bisect each other. That's true about all parallelograms, okay, and we put that on our family tree. But because it's also a rhombus, all four sides will be congruent to each other, and then the diagonals are perpendicular. They meet at a right angle, and the diagonals bisect the opposite angles. Excuse me. Okay, so if you draw a diagonal, it's going to chop in half each of these angles that it intersects with. And so there are some theorems. They're not incredible. I mean, they basically state what we've already learned. There's a rhombus perpendicular diagonals theorem, which means, oh, wait, if you have a rhombus, guess what? The diagonals meet at a right angle. Cute, okay? Also, the rhombus diagonal bisector theorem, meaning if you draw the diagonals, each diagonal intersects and bisects the angles that it meets. So this angle here gets bisected into this angle with this one here, as well as this one right here matches this one right here. The other diagonal chops in half this top angle, so this guy matches this, and this guy matches this right over here. Okay, so the diagonal bisector theorem. And then there's a theorem that says, hey, guess what? In a rhombus, all four sides have to be congruent. Guess what? If two consecutive sides are congruent, the rest of them will be congruent as well. So it's not overly thrilling, but it kind of talks about the properties of a rhombus. Okay, so it's all the parallelogram properties with three additional ones, which mean, hey, guess what? The sides are congruent. The diagonals are perpendicular, and the diagonals bisect the opposite angles from each other. The next thing would be is we talk about a square. Okay, I'm going to try to scooch this over. I don't know if I can. Here we go. A parallelogram. Okay, we're rewinding a little bit. So what's the definition of parallelogram? Both opposite sides are parallel. Okay, and then there's other principles, properties of parallelograms that also prove it. If you spy a shape that has two pairs of opposite angles congruent, it'll be a parallelogram. And then a rectangle. If you have a parallelogram in which all the angles are right, it's going to be a rectangle. And that means that each angle is right and that the diagonals will be congruent. So those are the additional features of a rectangle. A rhombus has the features to be all the sides are going to be congruent. So as a result, the diagonals will be perpendicular, and also the diagonals bisect the opposite angles. Okay, so those are the main two things to talk about that. Four congruent sides, perpendicular diagonals, and then also the diagonals end up bisecting the opposite angles. Now, if you have a parallelogram that obeys the rules of a rectangle and a rhombus, think about this. What is the rule of a rectangle? Well, four right angles. What's the rule of a rhombus? Four congruent sides. Can you think what shape you would make if you had a parallelogram that has four right angles and four congruent sides? Well, you'd get a square. Okay, four right angles and four congruent sides, that's going to be a square. So what's the definition of a square? A parallelogram has four right angles and four congruent sides. And so, if you start with a parallelogram, you've got, and it is both a rectangle and a rhombus, it will be a square. And so the properties of a square are basically all the properties of all the other shapes. So a square is a parallelogram. So opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are going to be supplementary. And diagonals bisect each other because it's going to be a parallelogram. Well, it also is a rectangle, okay? And so all the angles are right angles and the diagonals are congruent. I can write the word congruent, or I can use the congruent symbol. I'm going to use a congruent symbol because it also obeys the rules of a rhombus. All the sides are going to be congruent. Diagonals are going to be perpendicular, and they will bisect the opposite angles. So if you mark that here, you're like, I got basically all the things going on with a square. Opposite sides are parallel. Okay, cute. Diagonals are congruent, so that means all these diagonal pieces are going to be congruent. We've got a right angle for everything, right? Also, all the sides are congruent to each other. Okay, consecutive angles, yeah, they make 180. But let's see what else. We have a right angle in the middle, so these diagonals meet at a right angle. And I'm trying to think what else we missed. There's a lot of things with a square, aren't there? And so we can use these and say, look at your family tree and let's try to fill out the answers to these questions here to be like, okay, which shapes have diagonals that are perpendicular? Okay, well, we learned that today. So look back at your family tree and you'll see, that the ones that have diagonals that are going to be perpendicular, okay, that's going to be a rhombus and then also a square. Okay, so let me see if I can get this here. So a rhombus, there's a rhombus right here, and also a square because these have perpendicular diagonals, okay, and so squares follow the same thing. So rhombus and squares have that. Okay, if you go back over here, oopsie. Let's see if I can get this to move. Oh, I don't know if I can get it to move carefully. So diagonals being perpendicular, that's a rhombus and a square. Rhombus and square. Okay, who has diagonals that are congruent? Well, that's a rectangle, and it's going to be a square. Okay, if you think about, the only way that this is going to match up and those would be congruent would be as if it's not like slanted to the right or left. Okay, parallelograms or like rhombus will not have matching lengths of diagonals. Diagonals that bisect each other, that's everybody. That's a parallelogram, that's a rectangle, that's a rhombus, and that's going to be a square. Diagonals that bisect opposite angles, okay, that will be a rhombus, and it's going to be a square. Okay, if you draw those, a rhombus and a square are going to be that. And if you look at those shapes, it's kind of cute because if you look at a rhombus, the reason why they get bisected is because all the sides are going to be congruent. And so the angles have to match the sides that are across from them. So therefore, that's why they get bisected. So opposite sides being congruent, well, that's going to be all of them. That's a parallelogram, a rhombus, a rectangle, and a square. Consecutive sides that are congruent, would be a square and a rhombus. Okay, square and a rhombus. Opposite angles congruent, that's all of them. Okay, a parallelogram, a rhombus, a rectangle, and a square. And then consecutive angles being congruent, that would be both a rectangle and a square because they're all 90. The other ones have opposite being congruent. Okay, so now we can look at the problems that we see here. And these are going to take a little bit of effort. But I think the first one is, okay, if you see CDB, so CDB is right here, okay? And they tell you that's 6y. And then they tell you that ACB, so ACB, that's up here, and they tell you that is going to be 2y plus 10. Like, this does not help us. Well, remember, if this is a rhombus, both these angles here are bisected, or so they're going to be congruent to each other. So this right here is also going to be 2y plus 10. Like, that is still not helping me. Then you got to realize, guess what? We have right here in our cute little hands a triangle. And furthermore, because it's a rhombus, how do those diagonals meet? Well, they meet at a right angle. So this is 90. So if you add up 6y plus 2y plus 10 plus 90, you're going to get 180 degrees. That's a triangle. And so if you combine like terms, you're going to get 8y plus 100 equals 180. Subtract 100 from both sides, and you're going to get 8y is equal to 80. and y is equal to 10. So I think you've got to remember that the diagonals meet at a right angle. And so when you remember you've got a shape that's a rhombus or even a square, those two are ones that meet at a right angle. The second one says, if the measure of angle ABD is 60 degrees, okay, so, they kind of erase this and say, okay, if ABD is 60 degrees, what would be this measure down here, BDC? Okay, well, these two would both be equal. So this would be 60 and this one right here would be 60. So would be the opposite angles who are going to be bisected. So both of these down here would be also 60 degrees. So this would be 60 degrees. So remembering, hey, the diagonals meet at a right angle. Also, the diagonals chop in half the angles, the opposite angles. So if one's 60, then the other will be 60 as well. And the total across from each other would be 120 on each side. The one at the bottom, it says, hey, if PK, it's a square, if PK is going to be 5. No, actually RK, I lied. So RK is 5, okay? Well, in a square and in a rectangle, okay, you know that all those segments are going to be congruent in the middle, okay? With the rhombus and with a parallelogram, not so much. But we know these match. And we know that since the diagonals are congruent in both rectangles and squares, these will both be 5s. Now, the next thing is we remember that the diagonals meet at a 90-degree angle on both a square as well as a rhombus. And so they're asking us to find, what is it? PK. So where's PK? Oh, that's going to be 5. Well, that'll be easy. They ask us for YZ, and that's right here. Then you got to think, I've got a right triangle. So I can go 5 squared plus 5 squared equals x squared. A squared plus b squared equals c squared. That's 25 plus 25, which is 50. Square root it. Square root of 50 breaks up into the square root of 25 times 2, or 5 radical 2. So that would be 5 square root of 2 units. You could do the square root of 50 on your calc and you get 7 point something. So these lengths are going to be 5 units and then 5 square root of 2 units. The angles they give us would be nothing. You're like, but we know we've got the diagonals meet at a right angle. We also know that it's a square. So all 4 corners are 90 degrees. So YKZ, where is that? YKZ, oh, that's 90. That's right in the middle here. And then we also know ZRP. So where's ZRP? So ZR. And then P right here, that's right here. What would that be? Well, because we have a square or a rhombus, you know that it bisects the opposite angle. So this diagonal chops in half this angle here. Well, this angle is 90. So if it gets chopped in half, how much would that be? 90 divided by 2 is 45 degrees. All right. Thank you so much.